Hello everyone, welcome back to my channel. So today I have come with a new video on physics and the name of the topic is motion in one dimension again. But today's video is going to be an interesting one because today we are going to study the most important part of the chapter as well as the most scary part of the chapter, that is graphs. Okay, so today I'll try to make you feel a bit of relaxed from this particular topic because it's the most horrible topic of the chapter. Though physics is never horrible, but still people perceive it as an horrible part. So I'll try not to make it horrible and make it easy. I'll not talk about many things about graph, but the most important things about graph I will be telling you in today's video. In my previous two videos, I have already explained you the basics in one of them, and in the second video of this particular topic, I have explained you the three important formula along with the derivation formula wise. Today we are going to learn graphs and then I will show you how to derive the three formulae using graphs. Okay, so today let us know the basics of graph and let us get finished off with this particular topic. So under the chapter motion in one dimension, the most important part that lies is none other than your graph. What is graph? What is graph? Graph is something like this. Graph is something like this, where we have two axes. Okay? In maths, there is one chapter which is called coordinate geometry. Now, I'll not talk about maths right now, but still, let me tell you a bit about coordinate geometry. Coordinate geometry, basically, we have axes like this. Okay? This is 1, 2, 3, 4. These are called quadrants. Okay, in coordinate geometry, these four parts are called quadrants. This and these. These are the four lines that is playing the main role. This line is known as y-axis. This line is known as x-axis. Okay. When we are going upward, then the value will be positive. Okay, like +2. +3, +4 or only 2, no need to mention any symbol, sorry not symbol, sign. And if you are going towards the down, then basically there we have y negative, there we have all negative values. Similarly for x, if we are going this side, then we have x positive, and if we are coming this side, then x becomes negative. Okay? Not x, but the value that we are going to represent on this particular axis will be negative. X does not become negative. X is the name of the axis. Okay? But the value that we are representing on this line is negative. Okay? Now, all the graphs that we are going to construct today will be in the first quadrant. Okay? First quadrant and few of them will be in the fourth quadrant. We will not be constructing any graph on second and third. Okay? Most of the graphs will be in first, that means both the value will be in positive. This side, that is, this is your y, this is your x. So this, if you are considering only this portion, see, isn't it looking similar? Right? So here we have all the positive values, here also we have all the positive values. Sometimes we have to draw down, that is your x negative. Sorry, not x, y. We have to take the fourth quadrant because sometimes negative value comes. Now we will see how. Achha. So far we have learned one thing, that is how graph looks like. This is how the graphical representation is done. Let's forget about negative part. Let's only take positive. This is how your graph is constructed. Done. This is your y-axis. This is your x-axis, not y. This is your x-axis. this is a y-axis. Simple. Now this particular portion where both the axes are meeting, that particular point is 0. Just know this. This particular point is 0. Okay? Suppose something we are starting from here. Something. What is that something? We will come to know. For the timing, just for something. When we are constructing something from here, then the value is always 0. Be it y-axis, be it x-axis. For both the axes, anything that we are starting from here is 0. Done? Now, graphs are of 3 types. For physics and for class 9's physics of the chapter motion in one dimension, we have only 3 types of graph. First is displacement time graph. Displacement time graph. What is displacement? I've already explained you in my previous video, but still I am telling. The shortest path between the 2 points. That is your displacement. But for class 9, many questions that I am going to discuss, maybe today or in my next video. If possible, I'll complete it today. Since this chapter is a vast one, chapter is small but the explanation is vast. Therefore, maybe I will continue this particular topic till another video. Okay, I'll not be able to complete in one video, but at least this particular topic I'll explain today. Okay. So displacement, in many questions you will find instead of displacement, distance is mentioned. So one thing you need to be very clear, that is, many questions will either tell you displacement or tell you distance. Just remember, be it distance, be it displacement. Both the things are going to be same. Okay? Displacement and distance are poles apart different. They are not at all same. But for graph, we will consider it to be same. Okay, we will consider it to be same, but actually they are not. Since this is the first time we are learning all this, so distance and displacement, these two will be same for us only for graphs of class 9. Clear? For the chapter motion in one dimension. Okay, nail it in your mind. Never think they both are similar. They are poles apart different, but questions will tell you distance. You have to understand that maybe it is distance. Maybe it's given in the question that it is distance, but I have to consider it to be displacement. And we are not to be deflected from our concept. Whatever it's written, we will do as per instructed. Done? Number 2 is velocity time graph. This is number 2, velocity time graph. And number 3 is acceleration time graph. Number 3 is acceleration time graph. These are the 3 graphs that we need to be clear with. Nothing else. First, let us be clear with one thing. This x-axis is always time. X-axis is always time. Okay? Be it displacement time graph, be it velocity time graph, or be it acceleration time graph. Everywhere, x-axis means time. On x-axis, we will denote time only and nothing else. Only y-axis will vary. Either y-axis will be displacement, or I am writing in short, okay, or the y-axis will be velocity, or the y-axis will be acceleration. That's it. This will change as per requirement, but this will remain fixed. Done? Now, before knowing, at first I today I will discuss about displacement time graph. Okay. Before knowing what is displacement time graph, at first let us know one thing. At first let us know two terms related to graph. Number one is slope. Number two is area. Number one is slope. Number two is area. Suppose I have drawn one line like this. Simple line, we don't know what is it. And now it's a common idea since it's a topic of class 9. This you have saw that numbers are marked like this on a graph. Okay, at regular intervals, lines are drawn and numbers are marked. Like here 0, 1, 2, not 0 since 0 is also already mentioned here. Starting from 1, 2, 3, 4, 5, 6 and so on. Here let it be 2, 4, 6, 8, 10, 12, 14, 16. Remember one thing, whenever we are marking on a graph, we cannot do like this. Suppose this is the y-axis. We are writing 1, then we are writing 5, then we are writing 2, then we are writing 6. This is not going to work. There need to be one relation. Like here we have plus 2 relation. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. Maybe it's not visible to you since I have written in a very small handwriting in video. Maybe it's not visible to you. But I have given a difference or between the two numbers. There is a difference of 2. Okay. So we cannot draw like this or we cannot write like this. Rather, there has to be some relation. Suddenly we cannot put 1, then we cannot put 5. No. Whatever the question has told you, you have to be specific about one thing, that is the markings that you are doing has to have some relation. Okay? Either you increase it by 2 or you increase it by 10 or you increase it by 5, but it cannot be like this. Okay? Same goes for your time axis. Here I have given a difference of 1. 1, 2, 3, 4, difference 1. I can even draw it as 1, 3, 5, 7, difference of 2. So like that, you need to be specific about this particular thing. So I'm just increasing the size of this. It will be easier for you to see. Hope it's visible now. Now suppose we have just drawn a line like this. Okay? Don't know what is it mentioning. No need to know anything. Just understand one fact. There is a line like this. Starting from 0. This I have told you in the beginning. That this point is 0. Okay? I am telling you once again. The point where x and y axis meet. That particular point, for the time being, we will be giving the value as 0. Okay, we will not change the value. This particular starting point has to be 0. Okay, since we are learning the basics. Now, from this, let's measure one thing. This is read 16. Okay, we are measuring with respect to y-axis, this is your y, this is your x. With respect to y-axis, if we are measuring the, the length of this, then it is 16. And here also we have to mention it is 6. So I have told you that this is time axis. X-axis means always time. And this axis is none other than your displacement. Okay, this is your time axis, this is your axis which represents your displacement. Since I am talking about the first part. Done? Now in questions you have often solved that a body X have travelled 16 meter in 6 seconds. Okay, it's a common statement. Or a body has covered 5 meter in 2 seconds. 16 meter in 6 seconds. Common thing that we are all have saw while studying the chapter or somewhere while studying physics. This is a common statement. That particular statement, when we are graphically representing it, this is how the picture comes out to be. I repeat, suppose a statement is given, a body X covers 16 meter in 6 seconds. Displacement SI unit meter, time SI unit seconds. So in 6 seconds, the body covers 16 meter, right? That is what the statement is trying to tell us. So can you just relate the statement with the graph? Can you relate? Can you find any relation? If you have found the relation, very good. If you have not, let me show you the relation. 16 meter in 6 seconds. Right? Now let this line, let the body be a point. The point at first was at 0. Okay? At 0 second. At 0 second means time cannot be constant. Okay? So better we can say that when the journey did not start, the time of the journey is 0, right? It will be more specific or appropriate to say the time of the journey is 0 since the journey have not started only. And simultaneously the displacement is also 0 since the journey has not started. Before the start of the journey, the time of the journey is 0 as well as the displacement cover or the displacement or let it be distance. The distance covered by the body is also 0 since the journey have not started only. The body have not started only. If I am standing in this position, my journey is not starting. Will I cover any displacement? My displacement will be 0. Since my initial, final, everything is same. The point is same. Even my distance is also 0. So, at this point, the body was having 0 displacement since the body did not start its journey only. As well as the time of the journey is also 0. The time of the journey, note the point. Time of the journey, that was also 0. And the displacement was also 0. So at this point, 0. Now, in 1 second, the body covers 2 meters. I am making a small change in the graph. Just a second. Since I have started with the basics, let the graph be small. Okay. So I'm just changing the statement. 8 meter in 4 seconds. The body covers 8 meter in 4 seconds. Same thing. There I have told you 16 meter in 6 seconds. Here I am telling you 8 meter in 4 seconds. Done? Now, we need to note one thing. That is, this particular measurement has to be accurate. Okay? Earlier I did one mistake, that is 16 meter in 6 seconds, that should be 16 meter in 8 seconds. Okay, my measurement was wrong. Since I am not using scale over here, okay, I am doing by estimation. Therefore, I did my line that I have drawn was wrong. That's why I changed it. Now it's correct. 8 meter in 4 seconds, and I reduced the size of the graph also. Since there may be people, by seeing the size only, they will be scared. Okay, since many people are hating this particular topic, but believe me, it's an interesting one. So 8 meter in 4 seconds. That is what the statement is telling you. Maybe I'm trusting you that this particular thing is tough for you. But this is easy, right? This we have saw in many places. A body X covers 8 meter in 4 seconds. This statement is common to you. Values are different, but the type is same. So now, when we are representing this in graph, this is what it comes out to be. 8 meter in 4 seconds. Done? So I'm just drawing a graph like this, 8 meter. So the body has covered 8 meter in 4 seconds. Easy. Now from this, we have to know two things. Number one is slope. Number two is area. What is slope and what is area? Using these two, we will do our chapter graphical representation. Using these two, numericals will come from graph, but numericals will consist of this particular portion only. Whatever formula you will apply, the two formula only you have to apply. That is either of slope or of area. Now, just know one thing. If I tell you, at first let me tell you what is slope. Slope is y-axis by x-axis. Y-axis by x-axis. This may be, it may seem to be a difficult thing, but it's very easy. Y-axis by x-axis means the value of the y-axis that we have plotted by the value of the x-axis that we have plotted. Okay? So what will the value we have plotted here? What is the value? H. See, this is only we have plotted, and here we have plotted this. So what we can say? We are talking about the slope. Here we have plotted what? 8. And what we have plotted here? 4. 2. This is the slope. This is the slope. But if we are doing in this way, in many schools, you will get 0. Why? Answer is correct, but the process is wrong. Because we need to always do y2 minus y1 by x2 minus x1. Now what is y2, y1, x2, x1? y1 is, suppose the point that you have plotted is y2, and on the x-axis the point that you have plotted is x2. Another point you have to plot that will that will be your y1 and x1. On x-axis you have to plot another point that will be your x1, and you need to plot another point on y-axis that will be your y1. Okay, so now let me plot 2 over here. This is your x1. Here I can plot 4. This is your y1. Now you cannot do. Here we are plotting 2. Here we are plotting 6. No. Now, how to be specific about this matter? Use your scale, draw lines like this. Draw lines like this. Okay? That will make you sure that yes, in 2 seconds body have covered 4 meter. In 1 second the body have covered 2 meter. Okay? And so you will not do that mistake, like if we are using 2 here and if we are plotting 6 here, then that will be wrong, because in 2 seconds the body is not covering 6 meter, the body is covering 4 meter. How are we confirm about that? How to make ourselves confirm in the examination hall? By using a simple 2 things, scale and a pencil. Just plot it using scale and pencil, just join these 2 things. Okay? And that will give you your correct value. So I have plotted here 4 as y1, I have plotted here 2 as x1, I have plotted here 8 as y2, 4 as x2. Now y2 and x2 will be your concerned points, the points that you have intentionally or according to the question you have plotted. So my question was 8 meter in 4 seconds. So that was my question. I had to intentionally plot it. Here also I plotted intentionally, but that was my thing that was asked to me, or this was the thing that I need to do with the graph. So I have marked here 8 and 4. And another point you have to plot that should be less than these 2 values. See, I can mark 5 and I can plot that also. If you are making 5 here, then again you have to make 12 here. But that will be again wrong. We need to always choose value which is always less than the marked one. And the marked one means the marked or the plotted points which is based on the question. I repeat, the point that you will be choosing for this subtraction purpose, that should be less than the points that you have plotted as per the question. So as per the question I have plotted 8 and 4. So see, here 4 and 2 is less than y2 and x2. Right? y1 is less than y2, x1 is less than x2. So here what we can do? y2 is what? 8. y1 is what? 4. x2 is what? 2. No, sorry, x2 is 4. y2 is what? 2. So 4 by 2 equals to 2. Right? Answer was same. But this is the actual process that you have to do. No need to write any statement. This is the most amazing point of graph. In physics, everywhere you need to specify. Right? You need to write statements. Otherwise, school will not give you marks. But only for in case of graph, nothing has to be written. Directly you write the answer. Okay? Now, if you notice, in a minute basis, you will see one thing. What we did? Slope is y-axis by x-axis. This only we have learned. Here I am not plotting y2, y1 since we are not doing any numerical. Normally, what we did, x-axis, y-axis by x-axis. What is your y-axis? Y-axis is displacement. Let's write displacement over here. What is your x-axis? Time. Writing time here. Can you relate something with my previous video seeing this? Yes. What is the thing that you can relate? Displacement by time is velocity. See, such an amazing thing that we have got. So far, people who are very much new to this topic, they were thinking about something else. They were thinking, oh, y2, y1, x-axis, y-axis. But they did not notice this only. Y-axis means what? Displacement. X-axis means what? Time. Displacement by time means velocity. And I have told you, sometimes here you will have distance. Distance by time will be your speed. Again one thing, for class 9, speed and velocity in case of graph will be the same. No difference. Normally they are poles apart difference, but for speed and velocity, class 9, this chapter means while doing the numerical of this chapter, you have to consider like the way you have considered displacement and distance same, displacement and distance same for this particular topic. Similarly, you have to consider velocity and speed to be same. This was all about your slope. Next, coming to area. Area is finding area of displacement and time. You will not find or get anything. Okay. For your displacement time graph, if you find area, you will not find anything. Still, I am telling what is area. Suppose I have got some graph like this, and the graph is like this. Okay, again, same thing. Now, suppose the graph is velocity time graph. I will explain you velocity time graph in my next video in a detail, like the way I explained you displacement time graph today. Just know this, what is area, a basic idea I am giving you. Like here, if you are doing the slope, then what we will do? Y by x, y-axis by x-axis. What is that? Velocity by time. I am writing in short. That is what? Acceleration. So finding slope of velocity time graph gives you acceleration. Now, area is, suppose I am drawing a line like this. Okay? I am drawing a line like this. Obviously, you will have values here. I am not writing any value. You will have values here also. Okay. So, if you are finding the area is the mathematical formula that you have to apply. In maths, you apply the formula for area. Same formula you have to apply here. What is this? This is a triangle. This is a triangle, right? What is the formula of triangle? Means a formula of area, half into base into height. Half. What is the base? This is the base, right? Let the base be small b. What is the height? This is the height. So just plot it like this and you will get the height. Let the height be small h. So bh by 2 will be the thing. Okay. Here I wrote bh by 2. When you will get values, just multiply. Now if we are finding what we did velocity into time, right? By finding the area, we actually multiplied velocity with time. Now see, if we are multiplying velocity into time, then what we are getting? We are getting displacement. See, displacement by time is velocity. Velocity by time is displacement. So if you are finding the area of velocity and time graph, then we are getting displacement. So can you find relation? Is it becoming interesting? This is the way how you need to learn graphs. Okay? Acha. So, 3 things I tell you about graph. Means displacement time graph for today. And we will end up with today's video. In the beginning I told you I will tell everything in today's video. But it will not be possible since I am explaining you in a detailed manner. Three things that we have to know. First is, for displacement time graph, a stationary body. Achha, what is a stationary body? Like suppose if we are keeping a pen on, I am keeping a pen on my hand. Is the pen moving? No. Is the plane, sorry, not plane, it's a pen. Is the pen having any displacement? No. Can the pen walk that it will cover displacement? If you are keeping it in this position, it will remain in this position. Suppose my hand is a table. Consider keeping the pen on the table and I am giving it like this. So it's a stationary body. So is it having any displacement? No, displacement is 0. But see, if you see your clock, time is going on, moving forward. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, like this it is going on. But displacement is 0. How to plot this? This is your displacement, this is your time axis, xy. How to plot this? What I told you, this is your 0. Just take a pencil and draw a line on the x-axis. Why did we draw a line on the x-axis? Common question. See, the displacement is 0, but the time is increasing. Time is increasing in this way. Arrow means what? Line is increasing like this. Line is going on increasing. Time is going on means it is going on increasing. It is moving forward. Time. So this line is going forward. See, that means which is indicating that time is increasing, but the displacement is 0. See, the displacement is 0. Now body moving with a constant velocity. Constant velocity means what? Constant velocity means equal distance in equal interval of time. Right? So, equal distance in equal interval of time. If it is equal distance in equal interval of time, that means what? The displacement will be like this, the first thing that I have drawn. Right? So suppose I am doing the markings. I am not writing anything extra. So when we are talking about equal distance or equal displacement in equal interval of time, that is your constant velocity, right? So equal displacement in equal interval of time. And this particular position or this particular shape of the graph is called ramp. What is it called? Ramp. Okay? Ramp itself does not have any big definition, but this particular shape is called ramp. Okay? So equal distance or equal displacement in equal interval of time. So constant velocity or constant speed. Now body which is a free falling body or constant acceleration. That means the body is having acceleration. That means what? Equal or rate of change of velocity. That means with each what should I say? With equal interval of time, there is an equal increment of velocity. Like for first second, the velocity increased by 2. In another second, the velocity increased by again 2. Like this. So with each second, the velocity is increasing by 2. So equal increment in velocity in equal interval of time. I have already explained you in one of my video. So how to draw that? Now their displacement is not same. At first instant what happened? Suppose the body is moving with 2 meter per second speed. So in per second it is covering 2 meter. Now if the body is having an acceleration of 2 meter per second square, then in the next interval the velocity will become 4 meter per second. So see, the displacement becomes 4. It is no longer 2. Time interval is same, per second, 1 second increment. But the displacement changed. So in that case, we are seeing variable displacement. That means displacement is going on changing. So free falling body means what? If we are releasing a body like this, now it will be increasing by acceleration of 9.8 meter per second square. Why? Because that is the value of g, acceleration due to gravity. So if a body is moving towards the earth, then there is an increment in the velocity due to the application of value of g in the velocity of the body. So the displacement that was covered earlier will not be equal to the displacement that is being covered now, since acceleration is applied to the body. So in that case, displacement is like this. The displacement time graph is like this. Okay, this shows that displacement is not equal. So this was all for today. We will be doing the numericals of this particular chapter. At first I'll explain you all the 3 types. First type I have already explained today. More 2 types I will explain in my next videos. Then we will do some numerical, and then we will be doing the interesting part, that is derivation of the 3 formula that I have already shown you in my previous video by graphical method. We will be doing the derivation by graphical method. And obviously I will do some numericals after explaining all the 3 types of graph. Slope and area, that is a common to all the graph. If you have understood slope and area, well and good. In my next video also I will again explain you slope and area. but that will be for either velocity time graph or acceleration time graph. So this was all for today. Hope you have liked my video. If you like my video, please like, share and subscribe it, and also press the bell icon to get the notification of my uploaded video. So till my next video, bye.